So in this part of Unit 2, Solving Linear Equations, we're going to continue our work with word problems to construct equations to model verbal situations, and then solve those equations and interpret their solutions. So in example 1, I have the situation of Kim has a job where she makes $8 per hour plus tips. She made $13 in tips, and yesterday she made a total of $53. So one way that I might visually represent this is possibly using the balance scale. Remember, my balance scale shows that I have two equal things. And so on one side, I've got a paycheck, some writing, and it's worth $53. And on the left side, I would have where that money came from. So maybe it came from the tip jar that has $13 in it. And then I also have every hour, I'm going to represent these using blocks, every hour that she works. And I don't know how many that is, but I know that she makes $8. I should have dollar symbols. I should have zoomed in a little bit more. So I've got my tip jar with $13. I have an unknown number of hours, but $8 per hour. And I need to get it to equal 53, and that's represented by the fact that my scale is balanced. So then I can complete the table below for each number of hours. So if she had worked for 5 hours, then that would be 5 times 8 plus the 13. And so that would be 40 plus 13 would be 53. I may have inadvertently solved this equation, but I'm going to keep going for my numeric. And so if it had been 10 hours, $10, 10 hours at $8 per hour would be $80 plus the 13 in tips. That would mean that she made $93. Or for 20 hours, 20 times $8 per hour would be $160 plus 13 would be $173 total. So now my algebraic equation to model the situation. Remember, when we construct or write our equation, we want to write a generic equation that would work to solve for our unknown number of hours. So usually when I do this, I want my equation to equal my total, which is going to be my $53. And on this side, I want to show how I'm achieving that total. That way, if this number were to change, I could still use this equation to solve for X. You know, maybe this was on Monday, and maybe on Tuesday she makes a different amount of money. So I'd want to be able to change that number, but still solve and be able to find my variable. And so to do this, I'm doing 13 for my tips plus $8 per hour. And so that's going to be my algebraic equation. Now I'm going to solve my algebraic equation, which hopefully I get 5 for my answer, but we'll see, to see if that's the number of hours that she worked. So I've got my algebraic equation, 13 plus 8x equals 53. I would use reverse PEMDAS to get x isolated, so I would first subtract 13 from both sides, bring down my equal sign, 8x equals 40. Then I would get 8 to 1 by dividing both sides by 8, and I do in fact get 5. And so that would mean if I were to maybe write this answer in a verbal way, I could say that in order to make $53, she needed to work 5 hours. So in example 2, we're going to fill in each of these independently, but let's talk about the verbal model first, and then we'll take them one at a time to make sure that before we do numeric, we've got the visual, and before we do the algebraic, we've got the numeric. So we said we helped a friend move recently, and they rented a truck for $15 an hour, and then they also rented a dolly for $5. So that dolly is kind of like one of those things you can stack boxes on and wheel around. So that's just a one-time fee, and they paid a total of $80 for the rental. So the first thing I'd like you to do is to use a visual to represent this. You can use the balance scale, or you can draw your own visual to show that the amount of money that they spent has to equal the total. Pause the video, press play when you're ready to check your visual. So on my visual, I let one side of my balance scale equal $80, and so that means the other side of my balance scale needs to represent where the $80 is coming from. And so it was $5 for the dolly, and then I didn't really know how to represent hours, so I just put the moving truck and I put a ... to show that it's unknown, but I also made a note that it was $15 per hour. I wouldn't want someone to think that it was $15 per truck. So that's going to be my visual. So now what I want you to do is to complete the numeric table, and so you're going to find your total cost for 2 hours of renting the truck, 7 hours of renting the truck, and 10 hours of renting the truck. And so you're going to use this idea that it costs $5 for the dolly and then $15 per hour to complete this numeric table. Pause the video, press play when you're ready to check your answer. So for 2 hours renting the truck, I would do 2 hours at $15 an hour. That would be $30. But then I have to remember to add the dolly. That would be $35. If I had the truck for 7 hours at $15 an hour, 7 times 15 would be 105, and then add the dolly would be 110. And if it were 10 hours at $15 an hour, that would be $150. But don't forget the dolly for $5, which would be a total of $155. So now you're going to create the algebraic equation to model the situation. And remember, we want it to be our generic equation that's going to represent, in this case, our total. So when you set up your equation, you first obviously want an equal sign. The left side should your equation can also model your visual, right? So on the scale, the equal sign is this piece. And so however we're calculating it on this left side of our visual, we want it to equal our total on the right. So this visual might help you set up your equation. Pause the video, press play when you're ready to check your answer. And so in this case, on my left side of my scale, I have my $5 for my dolly, and then I need to add to that $15 per hour, so that would be 15x, and then that's going to equal my total, which in this case is $80. And it's important to make sure you identify your variable. I think I actually forgot to do this on this last one, so that way somebody looking at this would know that by x, we're talking about the number of hours. It's like a key to the problem. So now we're going to solve that same equation, 15x plus 5 equals 80, to determine how many hours the friend rented the truck. So pause the video, solve your equation for x, plus press play when you're ready to check your answer. So to get x by itself, I would use reverse PEMDAS. So I would first subtract 5 to make 5 0, which means I have to do it on the other side. My new equation would be 15x equals 75. And then to get rid of my 15, I would divide both sides by 15, and x would be 5 hours. This would mean that in order to pay $80 total, your friend would have needed to have rented the truck for 5 hours. So now we're going to deal with word problems where there's variables on both sides. So it says currently you have $80 and your sister has $145. You decide to save $6 each week while your sister decides to spend $7 each week. Create an equation to show when you and your sister will have equal amounts of money. So the first thing that we want to notice is that we want you or your money to equal your sister's money. Now, we don't know how much money each of you are going to have because it's going to depend on the number of weeks that you save for. But what we know about you is that you have $80 and you're saving money, so your amount is going to go up. And it says that you're going to save $6 each week. So that would mean after 1 week, you've saved $6, after 2 weeks, you've saved $12, and so on. And so what that would mean is that I could do 6 times x, where x represents the number of weeks, to find how much money I could add to my $80. For my sister, I know that she has $145, and since she's spending, her amount is going to go down, and hers is going down $7 each week, which means I would need to know the number of weeks and then multiply by 7. So like for example, let's say it was 4 weeks, that would mean $7 for 4 weeks would be $28. That should be the amount that I should subtract off. So the equation that I'm going to create is 80 plus 6x equals 145 minus 7x, where x represents the number of weeks. So now I'm going to solve that equation to determine how long it will take for the amounts of money to be the same. So I've got 80 plus 6x equals 145 minus 7x. So if I follow my flowchart, I first look to see if I distribute, which I cannot. These are not like terms, and these are not like terms. So my next step is going to be to balance my variables. So I'm going to choose to add 7x to both sides, because that will cause my negative 7x term to become 0. And so then my new equation would be 80 plus 13x equals 145. Since I ran out of room, I just rewrote my equation over here so I have room to work in the vertical format. So now I have to get x isolated by getting rid of both 13 and 80, which to do that I'm going to use reverse PEMDAS. So next I would subtract 80 because 80 minus 80 is 0, and my new equation would be 13x equals 65. And then I would divide both sides by 13, and so that would mean that x would need to equal 5 weeks. And so what this solution means is that it would take 5 weeks in order for me to have the same amount of money as my sister. And I can check this by doing 6 weeks, 5 weeks at $6 per week would be $30. Added to my 180 would be $110. Or 5 weeks at $7 per week would be $35. And if I subtract that from 145, I would get 110. Let's use Desmos graphing calculator to also check this. So on Desmos, I went and typed in 1/2 of my equation as my y equals 80 plus 6x. That was my money. And my sister's was y equals 145 minus 7x. And I can actually see that these do intersect when x equals 5. Now, not only that, but if you notice, the second number was $110, which when we checked our answer, that was the amount of money we both had after 5 weeks. So that's kind of interesting, and it's going to foreshadow what we're going to see when we get to the unit on solving systems of equations. So in example 4, we're comparing what it would take to be a member of a gardening association versus a non-member of a gardening association. It says that the membership fee for joining the association is $24 per year, and then it charges members $3 for admission. But if you're a non-member, you're charged $6, but you also don't have to pay that fee. So our first objective is going to be to write an equation to show when the cost of a non-member and a member will be equal. So you're going to write this equation, but what you're trying to determine is when the cost for a non-member is going to be equal to the cost for a member. So think about what it would cost for each of those types of people and write an equation to show when they would be equal. Pause the video, press play when you're ready to check your answer. So for a non-member, that was $6 for each admission. So that would be 6x, because if you go one time, it would be $6, but if you went, say, 3 times, that would be $18. Whereas for a member, you have to pay the membership fee of $24, and then you're adding to your cost $3 each time. And so x is going to be the number of times that we go. So now you're going to solve this equation for part B to determine how many visits it will take for the two costs to be the same. Pause the video, press play when you're ready to check your answer. So in order to solve this equation, I would first subtract 3x from both sides, creating the new equation 3x equals 24. Then I would divide both sides by 3 to get my solution of x equals 8 visits. So what this means is that it should take 8 visits in order for the cost for a non-member to equal the cost of a member. I could prove this by just checking what the cost would be for 8 visits for each type of person, a non-member and a member. So for a non-member, it would be $6 per visit times 8 visits would be $48. For a member, it would be $3 per visit for 8 visits for $24, plus their $24 fee, which would be $48. So for 8 visits, the cost for each would be $48. I could also use Desmos graphing calculator to check my answer. So on Desmos, I typed in the left side of my equation, 6x, so y equals 6x, and then I typed in the right side of my equation, 24 plus 3x, so y equals 24 plus 3x, and I saw that these two lines intersected here, which had an x-coordinate of 8, which matches my solution. But not only that, if you notice, it has a y-coordinate of 48, which is what we said the total cost would be for both members and non-members at 8 visits. So when we get further down the line, we're going to see that this whole ordered pair is going to come into play. So let's do this last example together. It says it takes 70 inches of ribbon to make a bow and wrap the ribbon around a box. The bow takes 32 inches of ribbon. So let's highlight this in green. So our bow takes 32 inches. So that's this piece right here. I'm going to make a note of that. Bow, 32 inches. And the width of the box is 14 inches. So that's here. And we can see that the height of the box is going to be x inches. And we've got a total of 70 inches. So when I create an equation to represent this situation, I want to make sure that I've got the amount of ribbon that I'm using to equal my total of 70. So let's see if we can figure out how much ribbon we're using. So let's say we started in this corner. Not that that's where you'd start to wrap a box, but it will just help us kind of visualize this. So keep in mind that I'm kind of going along the bottom of the box, but like in the middle here. So if I could actually draw this like 3-dimensional, it might look like this. And so what I'm really picturing is my ribbon kind of crossing across the bottom part here. I can do that with like a red line. I'm putting ribbon here. And that matches up with my 14 inches. So I've got 14 inches of ribbon going across from left to right. Then I would go up the side of the box, which is my height, which is X inches. So I'd add to that X. Then I would come back across all the way for another 14 inches. Then I would go down here for another X inches. So that would be the amount of ribbon that I would need to go across the bottom, the side, the top, and the other side. And then I also need the bow, which we've already decided is 32 inches. So I'd add that 32 inches, and that's going to get me my total of 70 inches of ribbon. So this could be my equation. I'm just going to simplify this to make it a little bit simpler. So I've got my x plus x, which I can make 2x. And then I've got 14 plus 14, which would be 28, plus 32. 28 plus 32, which would be 60. And so my simplified equation to represent this situation would be 2x plus 60. And so again, that's coming from my 14 and my 14 to make 28, x plus x to make 2x, but then my 28 plus my bow of 32 got me my 60. So now what I want you to do is to solve this equation to figure out what the height of the box would need to be, which is my x value, to make this situation possible. Pause the video, press play when you're ready to check your answer. So to solve this equation, I would first subtract 60 from both sides to get a new equation of 2x equals 10. Then I would divide both sides by 2 to get my solution of x equals 5 inches, which means that in order to use 70 inches of ribbon, I would need a height of 5.